Welcome to Mr. Chalk's Revision Tips. In this video, we will look at national grid, mains electricity and transformers. So electricity is transferred from power stations to consumers through wires and cables of the national grid. So when the current flows through the wire, some of the energy is lost as heat. The higher the current, the more heat is lost. So to reduce these losses, the national grid transmits the electricity to low current and a high voltage. So the way that it works is electricity is generated by power stations at around 20,000 volts. This is stepped up by a transformer to about 400,000 volts. The electricity is then transmitted using cables. It is then stepped back down to around 33,000 volts for domestic transmission before being reduced to 230 volts, which is then transmitted to people's homes. So a small community of people living in an area in the mountains, the houses are not connected to the national grid. Right, what might be some of the reasons why? So it might be the high cost of installing overhead power lines or underground power cables. It might have a very high cost for the cables, and the amount of electricity they actually need would be relatively low. So it would make more sense for them to go and set up some localized sort of generating station which could generate their electricity locally. So the national grid is used to transmit electricity. In it, it contains two different types of transformers. So a step-up transformer increased the voltage from generators at the power station for supply to the transmission cables, whereas step-down transformers reduce the voltage from the transmission cables to a safer level for domestic use in the home or commercially. So if we're looking at what the core of a transformer is made out of, it's made out of iron. If we're looking at the function of the transformer, it's to either step up or step down the voltage of electricity. What sort of current is needed by the transformer in order for it to work? It has to be an alternating current. If we think about how it works then, there's a few main things that we need to think about. So an alternating current goes into the primary coil, which generates an alternating magnetic field, then the iron core. So on the other side, that creates an alternating current or an alternating potential difference in the secondary coil. So an electric current flows through a thick cable held up by pylons. They will get hotter and disperse or dissipate energy to the surroundings. The electric power dispersed depends on the current and the resistance. So the equation that connects this is power is equal to current squared times by resistance, where the power is in watts, the current is in amps, and the resistance is in ohms. So if we look at an example, so if we have a current of 3 amps that flows through a 10 ohm resistor, calculate the power. So power is equal to current squared times resistance. So we're going to have 3 squared times by 10, which would give 9 times 10, which means that the power would be 90 watts. Thanks for watching.